Hello scrappers, welcome back to my channel. Today we are going to start processing the chips that Nick sent me in a recent mail call episode, and I'll put a link to that episode up in the upper right. Nick sent me, he said, a couple of kilograms of IC chips that he wants me to process for him. Because he has access to just tons of these. I mean, I've seen photos of his workshop. He's got big plastic bins full of IC chips. But he's been processing them on his own, and he doesn't think he's getting as much gold out of them as he should be. So he wants me to process some of these for him and see what I can get out and see if my process works better. So first off, let's weigh these. Let's get an accurate weight on these and see just how much stuff Nick sent me. This first bag, 2.02 kilograms. Put this second bag on, 3.11 kilograms. Let me give you a close-up view of that. So there we are, 3.11 kilograms of mixed IC chips, and there's a little bit of everything in here. There's a lot of dips, especially in this smaller bag, but there's some flat packs. Over here in this bigger bag, there's a lot more flat packs. I've seen some pieces of a Gold Corner BGA in there, some broken up tops. There's still a lot of dips in there, dual inline packages. So it's a real mixed bag of stuff we got here. So I was not expecting to get a lot of gold out of the dips, but the flat packs and the Gold Corner BGA bits, those will have a fair amount of gold in them. So, you know, it's going to average out somewhere probably close to the low end, I would think, due to the number of dip packages in there. But we'll find out, you know. This is an experiment. We'll find out exactly how much is in his 3.11 kilograms of chips. So, how am I going to process these chips? Well, I'm going to process them the same way I process my own IC chips. I've got some buckets here, and in the buckets are some baskets I made out of plastic strainers and some string, and these can be suspended down inside the buckets like so. And what I'm going to do is I'm going to load the chips in these strainers, and I'm going to put them in the buckets, and we're going to put a fish tank bubbler in the bottom first of each bucket, a fish tank bubbler with an air stone on the end to hold the hose at the bottom so it doesn't float up. And that'll be blowing air into the bucket. Then we'll load the chips into one of these baskets and drop it in the bucket and then put the lid on it and just leave it for a few weeks. You know, depending on the temperature, it's summer in Florida, so it's probably not going to take too long because this works faster at higher temperatures. I'm going to fill this up with some muriatic acid and some spent AP solution, and we're just going to let it bubble away for a few weeks to a month. And what it's going to do is it's going to dissolve all the legs off these IC chips over here, and that's going to get rid of all the exterior base metal on the chips. This is the first step in my process. It's the way I do it. Other people do it different ways, but you know, I'm too lazy to grind the legs off of 3.11 kilograms of chips. I'm way too lazy for that. I'm going to let the chemicals do the work. So let me get his chips in the baskets, and then we'll start filling up the buckets with the spent AP solution and the fresh muriatic acid, and we'll get this show on the road. So I'm going to sort of evenly distribute these chips, just, you know, eyeball it, between these two colander baskets here. And there's some stuff in here that's not IC chips now, I see. That's a resistor network. But I'll leave it in there. I don't honestly know if there's any precious metals in resistor networks. There might be. There might even be gold bond wires. Who knows? I'll leave them in there. We'll take them out. A few other things. Not sure what that is. I'd have to look the number up. It's not an IC chip though. And there's some bits of plastic. Now, on the whole, it's mostly just IC chips though. What's that? Ah, that's That's an LED display unit. Not a 7-segment. It's got a lot of segments to it. It looks like it could probably display Japanese kanji characters. Huh. Wonder what that came from. We'll leave it in, because there's probably a fair number of gold bond wires in there. Let's see. Let's see. There's some more plastic in here. I saw a steel screw, but it disappeared to the bottom. Oh well, I'm sure it'll dissolve with the rest of the metal. I was going to pull it out, but it kind of got away from me. Sort of get them even here so they'll process about the same length of time. That's a ceramic chip. Now we need to pull out the ceramic chips. That's not going to work with my process very well, especially when it comes to incineration and pulverization. I'm geared towards working with plastic, not ceramics. Ceramics take a whole different route. Okay, so got 2 baskets, pretty much equal amount of chips in them. Now I'm gonna put them in the bucket, and we're gonna get the chemicals on them. Okay, I've got my 2 buckets here. Now, first things first, this bucket here has some spent AP solution in it. It's probably actually not accurate to call it spent. I didn't dissolve that much material in it, so it's probably still got a lot of life left to it. I'm going to pour half of this roughly into this other bucket. The thing about spent or used AP solution is that it has a lot of metal salts dissolved in it, copper, tin, whatever, and it's very, very corrosive. So that's going to jumpstart the process of eating all of the metal away from the chips, the legs of the chips. Let me get my air stone and hose in this bucket, and I'm going to lower this basket in. Let me lower this basket in this other bucket. Now it's just a matter of adding muriatic acid until the parts are covered. Fortunately, muriatic acid's pretty darn cheap. That one was almost empty, but I've got 3 more gallons of it. That should hopefully be enough to cover up these chips and get this process going. If I don't have quite enough acid, what I'll do is I'll just top it up with a little water. There'll be plenty of acid in there to dissolve these chips. Open up this other one, and I have another one in reserve just in case it's needed. Wow, I don't have the air bubbler going yet, but I don't know if it's showing up. There is a lot of bubbling going on in there. So the acid alone, without the bubbler, is doing a really good job of dissolving the chips. This is something you want to stand upwind of while you're doing, by the way. Get a little bit more in there, a little bit more in there. Shake this and get everything dissolve or under. There we go. Okay. Wow, we got a really vigorous reaction going on in both buckets. That's great. So let me get the bubblers plugged in. With all the reaction going on, you can't even tell the extra bubbles coming up from the bubblers. So the air bubblers, what they're doing is they're supplying oxygen. It's sort of taking the part of the hydrogen peroxide in AP solution. I'm not going to put any hydrogen peroxide in. I'll just let the air bubblers bubble oxygen through the mix, and that'll keep it oxygenated, and that will greatly increase the speed at which all those metal legs are dissolved. By the looks of things, though, it may not take very long at all. I was thinking it may take a couple weeks, Yeah, we'll see. There's a lot of tin on the legs in the beginning, and the reaction is really fast. But once it chews through the tin and is just dealing with the copper and steel underneath, it slows down a lot. So now what I'm going to do is I'm just going to put the lids on the buckets, but I'm going to put them on very loosely, just so I don't kink the air hose. And I got to let that gas that's being developed in there and gas that's coming out from the air hoses, I got to let that out. So put it on loosely, and I'll put a heavy rock or two on top of the buckets just so the wind doesn't catch them and blow the lids off. And we'll just leave that. I'll look at it maybe once a week and just let them go until I don't see any more metal on the outside of the chips. Then they'll be ready for the next step in processing. So I'm expecting it to take at least a couple of weeks, maybe longer. See you then. Alright, I think it's time to have a look at Nick's chips. They've been soaking in these buckets for a few weeks now. Yeah, the buckets are filthy, as you can tell, so they've been here a while. I looked at these a week or so ago and they looked like they were about done, so they may be done this time. Let's have a look in this bucket first. I'm weighting the buckets down with geodes I've cut in half with the lapidary saw a while back. I made a video about that. I'll put a link if you're interested. Let's see what we got here. Got a little screen here. Let them drain into the bucket. A little bit of a wash here. Let's see what we got. I don't see any legs. Haven't we got legs? I see just the edges of legs. I need to let these go. Another few weeks, month. The legs will get chewed up into the plastic a little ways, but not too far. Just because there's not enough liquid circulation and fresh acid getting to them. So, yeah, this looks pretty good. That looks pretty good. Let me wash some of the acid off. Let it drain into the bucket. Here's a 40-pin dip right here, and I see no trace of legs on it. And this is a flat pack with probably 50 or 60 legs, and they're all chewed up into the plastic a little bit. Like I say, it won't go too far in. Some of them that probably didn't get too good a circulation, the legs are only chewed up to the edge of the plastic, but still, that's a big improvement over having to deal with all that leg metal. Let me give you a closer look at that. So, that's what we got right there. Ooh, I'm working my camera with acid-covered hands. That's probably not good for the camera. So there's that bucket. We'll just let that drain. Let me look at this next bucket over here. See what we got. All the acid condensation from the lid to drain back in the bucket. Yeah, these look about the same. Yep, they look like they're done. That was busted in half, and I see gold in it. Nice. Alright, so what I'm going to do is, I'm going to put this back in here for now, so I only have one screen to let it drain through. I'll let these drain for a while. Then I'll take these out and let them drain. Next step for these chips is incineration. And I'll get set up for that while I'm waiting for these to drain and dry a little bit. They don't have to be dry to go into the foundry, but doesn't hurt. So here we go. We put Nick's chips in this big crucible and cook it in the foundry to burn off all the plastic and all of the organic material here. First thing I'm going to do is I'm going to put this piece of brake line that's bent like this. It goes all the way down to the bottom of the crucible. I'm going to put that in. I'm going to start loading the chips in. The brake line is going to be hooked to an air hose, and it's going to send a trickle of air down to the bottom of the crucible just to ensure that all of the plastic gets oxidized. It doesn't just get pyrolyzed into carbon. I don't want the carbon remaining. I want that nasty black carbon all burned away, because the carbon is porous and will absorb gold later on in the process. It's almost impossible to get that gold back out of the carbon. So, what I saw, that's half of a ceramic chip there. I don't know where the other half is. I see a few flecks of gold in here, so that's nice. Yeah, there's gold has come out of some of these chips already. It looks like I'm not going to be able to get all the chips from this first load into the crucible. So that means I probably won't be able to get all the chips from the second load into the crucible either. So that means we're going to have to do 3 runs in the foundry. Yeah, there's little flecks of gold all over the place. But I know there's a lot more gold inside the chips, so we're gonna cook them. Alright, so there's another part of a ceramic chip. So a few ceramic chips snuck by into this. I'll probably find them after incineration, because they'll really stand out, because they won't change. Alright, so this is ready to go in the foundry, and we're ready to fire it up. Okay, so here's the foundry setup. Nick's chips are in the crucible. Crucible's inside. The brake line is coming out. The foundry is just made of a couple wraps of kale wool fiber insulation inside an old steel bucket, which is rapidly rusting away. You don't really need the bucket. Just a couple wraps of kale wool with some baling wire around it to hold it into shape will make a decent foundry. I got a couple pieces of kale wool with a hole in the middle for the lid. And I've got a reburner chimney here. Just a piece of sheet metal with some shark teeth shaped cuts at the bottom of it. I'll put that on top of the lid, and fresh air will go in through those cuts, and we'll reburn the smoke coming out of the foundry and have a lot less smoke and particulates coming out of this thing. It works pretty good. Got a burner here. It's going back to a propane tank over here. It's going to power it. And this foundry gets hot enough to melt copper, bronze, brass, aluminum, but I don't want to get it that hot. I don't want a puddle of mixed metals in the bottom of the crucible. Although, I could probably process that if I really wanted to. What I really just want to do is I want to thoroughly ash the IC chips. So I'm going to run the foundry until everything in the crucible gets good and hot, but not hot enough to melt the metals. And then I'm going to turn on a trickle of air. I've got this regulator hooked up to my air compressor, which is out of frame. And I'll just put a trickle of air in once everything's good and hot, and that air will go down to the bottom of the foundry, or to the bottom of the crucible, and it'll help burn off the carbon from the bottom up. Then I will really turn down the flame on the burner, turn the propane down, and get a nice good oxidizing flame in there, and that will burn the carbon from the top down in the crucible. And I just kind of want to burn the carbon slowly and gently. I don't really want to fan that carbon fire, because carbon burns really hot, and again, it will melt all that metal into a big lump in the bottom. I don't really want to do that. I just want to thoroughly ash the IC chips and burn off the carbon. So let me get the foundry put together, get my torch, and we'll get this thing lit and get this first load of chips going. I might actually, in the future, try smelting the chips. Heating them up enough for all the metal in them to melt. And maybe use a collector metal like a chunk of lead in there or something to melt and collect all the precious metals and base metals. and then refine that chunk of lead that'll be in the bottom of the crucible. But I may try that another time. But these are Nick's chips, and I'm going to go with what I know works with these. I'll do an experiment sometime with my own chips. Okay, foundry's lit. It's going to take a little while to get hot. I'll show you what it looks like when it does. It's been running for a few minutes. Things have gotten pretty hot inside. And you know, I did another video where I processed IC chips all the way through. I'll put a link to that video up in the upper right hand corner here. You can see some of the details just to keep this video a little shorter. But what's happening right now is the chips are pyrolyzing in here. They're getting very hot, and the organic compounds in the plastic they're made of is cooking off and getting up into the chimney here, mixing with fresh air coming down here, and there's like a fire tornado in the chimney. But all that's coming out of the chimney is hot air and a little bit of blue smoke. I don't even know if that smoke's showing up on the video. So it's working really, really well. I'm going to wait for the chips to get a little hotter and a little better pyrolyzed, and then I'll start the airflow. I don't want to do it too soon because the air actually kind of cools the chips. I want to make sure they're hot when I hit them with the air, number one. And number two, if I start it too early, I'll get a big billow of smoke coming out of it. And you know, I don't want to smoke up the neighborhood. So try to be responsible here. But we're almost hot enough, I think, to turn the air on. And the fire tornado in the chimney's gotten big enough that you can actually see it start to peek out the top now and then. But we're still not putting out a lot of smoke. This chimney really helps reduce the smoke. One of my best ideas ever. And I got the airflow turned on just to trickle. If I turn it up too much, I'll get a lot more smoke. And also, like I said, I'll burn the chips a lot too hard and all the metals will melt. I don't really want that. But things are coming along pretty darn good. Well, unfortunately, it is starting to rain. Hopefully it won't rain too hard. A little light rain isn't going to bother the foundry a bit. The temperature that's going on in there. This batch of chips is about done anyway. In fact, I'm going to turn the propane off and just let the air go with it now. I'll give you a quick look inside. Everything's glowing nice cherry red. So just got to let that cook with the air blowing on it. It's raining a little harder now, but I don't think the rain is going to make too much of a difference. That's the air compressor kicking on. I think this will finish up just fine, even in the rain. Just gonna let it go in that trickle of air for the next hour or two, and until the chips stop glowing, and then I'll know they're fully oxidized. Okay, it's been, I guess, hour and a half. Things have cooled down some, not so much that I can reach in there with my bare hands and grab anything, but there's no more glow down there in the bottom of the crucible. If I shade it, I can turn the air off now and pull that crucible out of there and dump the first load of chips out. And yeah, it looks like the rain has moved on. So I could probably get at least one more load of chips done today. Whew, you cannot imagine how steamy hot it is out here. That was the second rain today. Now the sun's back out full strength. It's August 1st in Florida. It's like 95 degrees and 100% humidity. And I'm running a foundry. All right, let me get those chips out and get a second load in. And I'll be back when they're all done. Okay, here we go with the second load of Nick's chips. With the rain delay, I don't think I'll get all 3 loads done today. But, so this will carry on for a couple days, but at least I got 2/3, I'll get 2/3 of it done today. And I'll give you a look at the first batch of chips to come out of the foundry. So here they are. They're still hot. Can't really mess with them without gloves on. So that's after. There's before. That's going to be the 3rd batch right there, what's left in that colander. And so, you know, before and after. And they're really crumbly. They're white. They're well oxidized. Oh, that's hot. There's, you know, not a lot of carb in there. That's absolutely perfect. There wasn't a puddle of metal in the bottom of the crucible, so I didn't overheat them. Everything just went textbook. So I think I'll have a good job processing these, and hopefully we'll get a decent amount of gold out of them, although I am a little worried about the number of dual inline packages here. They, for the most part, don't contain a whole lot of gold compared to, say, these flat packs. So we'll see what we get. Okay, finally, here's all of Nick's IC chips incinerated, oxidized. With the weather delays, that took a couple days, but finally done. Ready for the next step, which is going to be grinding up in my long-suffering Hamilton Beach blender. Gonna grind them up and see if I can get these turned into as fine a powder as I can, sift out anything that won't grind up, which is going to be mostly metal, and we'll go from there. And I have shown this process in I don't know how many different videos, so I'm not going to belabor it. I'll show you a load or two, and then you know, it's just going to be the same thing over and over again until I get all the ICs ground up. And here we go. Got myself some gloves on and a mask so I'm not breathing the dust this creates. Put the first load of chips in here. I'm going to overload the blender, and away we go. Maybe. Helps if I plug it in. Yeah, that's the stuff I don't want to breathe. Okay. What doesn't go through the screen goes back in the blender. Most of the bond wires are going to be in there. Put a little bit more on top. Do it again. So at the end, I am going to have some stuff that won't go through the screen. And I'll show you how we deal with that. But that's a ways off. I've got a lot of grinding to do before I get there. So, won't make you watch the whole thing. That escaped. It's going there. Won't make you watch the whole thing. I'll just take you to the end. Alright, I'm about halfway through Nick's stuff. I've got quite a bowl of gray powder here. This is the stuff that's gone through the sieve. I've stopped here because I'm getting quite a collection of stuff that won't go through the sieve, and I want to show you this. A lot of it is highly magnetic, so there's a lot of steel there. And I get questions in almost every single video I do about why don't I separate this out and throw it away. And I'll tell you what, I used to separate out, we turn off the compressor. I used to separate out the magnetic portion, but fortunately I did not throw it away. I kept it until it piled up, and I thought, I need to do something with this. Is there any gold in this? Is it just garbage to throw out? And I got to looking at it, and it's like, holy cow, that piece is gold plated. That piece is gold plated. That piece is gold plated. A lot of this magnetic stuff has gold plating on it. And as I root through here, I see more and more pieces that have a glint of gold to them. And I processed the big bag of magnetic stuff that I had set aside, and I got a significant amount of gold out of it. So I don't throw this stuff away. I mean, look at this. There's two pieces right there. They're probably not showing up on the camera, but there's two pieces right there with bright gold plating on them. And they're sticking to the magnet. And there's more down there I see. So I keep this stuff. Now I am going to process it separately from the powder down here, but this is all getting processed because this stuff has a significant amount of gold in it. So yeah, that's why I don't separate out the magnetic portion, at least not out of here. I mean, a lot of magnetic stuff made it through the screen, but a lot of that's probably gold plated too. So it's going to stay right there and get processed with this stuff. But this oversized fraction, this mostly metal, I'm going to process it separately, and we'll see how much gold I get out of it. And that should explain to people why I don't throw it away. Okay, so I'm done grinding up Nick's chips. I've got this big tub of the fluffy stuff, which should have most of the bond wires in it. And then we've got this, which is the heavy metal parts. A lot of steel in there, but there's also a lot of copper, maybe some silver too. All right, now I can see gold plating on a lot of this stuff. I'm sure it's not showing up on the camera, but I see it. So I'm going to process this stuff. A lot of people would just discard it. I'm going to process it. I'm going to do it separately though. In fact, I need to do a gravity separation on this, and there's a lot of material here. So I may do it in a couple of batches. I don't know, just so I don't, lose a lot of material. And I'm probably, even after the gravity separation, there's going to be a lot of stuff here, more than I would normally process at one time. So this may end up having to be done in several batches, just so I don't overload my beakers, because if I fill the beakers too much with the solids, the stuff at the bottom doesn't interact with the acids well enough. So this will probably be a couple different batches. So I got to do a gravity separation on this and then batch it out. So that's going to take a little while. It's already getting late in the day. But what I can do is I can get started on this stuff. I can put this stuff in a beaker and get it started dissolving right now. Let me grab a beaker out of my fume hood over here. This stuff in it. I will reposition the camera and we'll get started processing this stuff now while I work on this other stuff. And hopefully by the time this stuff's done-ish anyway, I'll be ready to start processing this stuff and I'll have room in the fume hood for it. Alright, let me reposition the camera and we'll get started on this. I've got The stuff that wouldn't go through the sieve, mostly metal, got it in the beaker, in the fume hood. I'm going to add a few hundred milliliters of water, about 600 it looks like. And I'm going to put some nitric acid to it and start dissolving all that metal. Now I admit it's going to take a lot of nitric acid. Nitric acid ain't cheap. It's going to take a lot of nitric acid to dissolve that metal. We'll see if we get enough gold out of this to make this a worthwhile exercise or not. But I did tell Nick that I was going to try and get as much gold out of this as possible so we could compare our different methods. So I'm going to try and get all the gold out. Let me get the fume hood running. We're producing a lot of fumes now. So I'm going to try and get all the gold out. So this is probably going to take a few additions of acid to dissolve all that metal. And we'll just let that cook. And once the metal is mostly dissolved, I'm also going to test it to see if we got any silver in there. Silver will be a nice little bonus. That is a seriously vigorous reaction going on in there. I haven't even turned the hot plate on. I forgot. But apparently it wasn't necessary to get things started. I'll have to watch that, make sure it doesn't boil over on me. I may have put a little bit too much acid in to start with. I think it's going to be okay though. I'll be careful on future editions though, because it'll be hot. Okay, this first edition of acid is almost done. Look how opaque brown the liquid has become from dissolving copper, nickel, iron, whatever all is in there. But that's what I wanted to show you, the stuff on the bottom. Now the gold-plated stuff is really starting to show up. Now that the dirty metal is getting dissolved away, it wasn't showing up as dirty and you know, burnt as the metal was. I could see it a little bit, but now that the metal's getting dissolved away, you can start to see the gold in there. There's a really nice piece right there in the center of the field. I get it to focus, probably not. There we go. Really nice piece right there, and I see others in there too. So I'm going to put this back in the fume hood and put some more acid on it and keep dissolving away that metal. It's been, I don't know, maybe 2 hours. I got busy with stuff and wandered away. But the second edition of nitric acid to this looks like it's about done. Really not much more in the way of brown fumes. A little bit of bubbling still going on, but that may be more boiling than anything. So what I'm going to do is I'm going to decant off this nasty brown opaque liquid, and we'll see what's in the bottom of the beaker. Metal in there, but boy, the gold plating really jumps out at you now. I don't know if that's showing up at all. But there's a fair amount of gold plating in there. So I'm going to put this back up here, and I'm going to put some more distilled water on it. Jug here. Not wearing my gloves, that's not smart. I get some gloves. And the other gloves on because it's hot. These gloves don't really protect you from the heat. Distilled water on it. Still pretty nasty looking in there. But I'm going to hit it with some more nitric acid and see if we get some more of that stuff, I'm sure the reaction will speed up. I'm pretty sure that the brown we got over here is from all the iron. I'm going to let this settle. I'm hoping that a lot of the sediment in it will sink to the bottom and we'll get a clear liquid near the top. And I'll be able to sample it and see if there's any silver in it. But I'm hoping it'll settle a little bit, be less turbid. It'd be hard to tell if there's a cloud of silver chloride testing that stuff. Well, we've had a bit of a weather delay here. Yeah, the weather has just been horrid for the last couple of days. In fact, it's raining right now, but it's only coming down lightly. But I think it's going to rain all day. We had thunderstorms this morning. Light rain now. There's more embedded thunderstorms in the rain coming in off the Gulf, so it's just going to be another nasty rainy day. But this has been sitting here for a while, so I'll give you a look at what's gone on here. 3 times now I have dumped the contents out of this beaker, decanted off the liquid into this beaker, and put fresh distilled water and nitric acid in here. After the 3rd edition, it looks like nothing much is happening anymore. I think all the metal that's going to dissolve has been dissolved. I have tested this fluid. This fluid has had a chance to settle now, just sitting here for a few days. It is a nice clear dark blue liquid with a, I don't know, maybe a 1/4 inch thick layer of brown crud at the bottom. But nice clear blue liquid. It is just loaded with silver. There's a lot of silver in there, and I'll do a test and show you the silver that's in there. There's a little bit of silver in this stuff too. I've tested it, but it looks like most of the silver came across in the first two batches of liquid. There's not as much in there as there is in here right now, strength-wise anyway, not just volume-wise. So I think we've dissolved about as much of the metal with nitric acid as we can. I'm gonna decant off this liquid too. There's probably still a little bit of metal in there. So I think what I'm going to do is I'm going to add a little sulfuric acid to it. Some of the silver that's in solution in there may precipitate out as silver sulfate, but I'm not too worried about it because most of the silver I think is in here. So I'm going to add a little sulfuric acid to that. See if I can get any more of the metal on the bottom to dissolve. There's not much left, but I think I see a few little wires and stuff down there. See if I can get that to dissolve. Then we'll decant off this liquid and we'll be ready to hit it with Aqua Regia and dissolve the gold. But first I'm going to show you how much silver's in this stuff. I'll pull this beaker out onto the workbench and we'll do a test for silver. Alrighty, I hope you can see how transparent this liquid is now that it's had time to sit and settle. It actually got transparent after only a few hours, but it's been sitting here for a couple days now. So I've got some tap water here. I'm going to put some tap water in this little beaker. Tap water, of course, has chlorine in it. At least here in the US. Your mileage may vary. Put a little bit of this stuff in it. Oh yeah. See that? See how cloudy that got? That is from silver. The silver nitrate in here, it reacts with the chlorine in the tap water to make silver chloride, which comes out of solution as an opaque cloud. So yeah, there's not that much chlorine in tap water, but to get this dark a cloud, there's a lot of silver in here. So that's good. Silver's a nice little bonus. And remember, this is just the stuff that wouldn't go through the sieve. There's going to be a lot of fine metal in that powdery stuff that's going to contain silver too, as well as the bulk of the gold. There's a little bit of gold in the other beaker, but most of the gold's going to be in the powdery stuff. So, you know, we're just getting started recovering precious metals here. We've got a long way to go. All right, I'm going to move the camera and we'll treat that stuff with some sulfuric acid. Alright, this liquid is already hot, so if I pour some sulfuric acid in here, there's probably going to be some ferocious boiling when it hits the liquid. And we're probably going to evolve a lot of fumes. So let me get the fume hood running. pour some of this in. Oh, not as ferocious as I thought. Okay, that's enough for now. I see some sort of reaction going on down there. I see a little bit of fizzing. So we've got something going on. That's a good thing. Yeah, starting to get some bubbling. So I'm hoping that sulfuric acid will take care of whatever metal's left on the bottom of that. We'll just let this cook for a little while. When it looks like it's done, I'll decant off the liquid and we'll be ready to hit this with some aqua regia and see what kind of gold content it has. Alright, while I'm waiting on the sulfuric acid to do its thing on that stuff, I'm just going to set this liquid aside, probably in the back of the fume hood out of the way for now. Once I think the sulfuric acid has done all it can do on dissolving the metal, I'll test that liquid in there and see if it still contains any silver in solution. There probably still will be some. And if so, I will decant it off into this and just let it settle like before. When I'm ready to, maybe towards the end of this process, I'll siphon off the clear liquid and we'll precipitate out the silver. We'll cement it out on some copper. But I'm just going to let this sit for now and work on other things. Alright, I hope we can get through this without incident. It's been raining for 2 days, and I tried to film this earlier, but the lens on the camera fogged up because it's so humid. But we're between rain showers. I've let the camera equilibrate. There doesn't seem to be any fog on it at the moment. Maybe we can get through this without it being foggy. So I've got all of Nick's ashed up IC chips here in this pan. Put some gloves on here. And there's an unusually large amount of it. I don't normally work with batches this big. So I'm going to be really careful when I do the gravity separation. I'm going to do it in a big bucket to make sure everything gets good and wet, because this stuff is a little hydrophobic. Doesn't want to mix with the water really well. I would normally do it in a bucket that size, but we got a lot of material here. So I want to make sure that all of it gets thoroughly wet. And it doesn't just sit on top and float away. So get it all thoroughly wet here, which is not as easy as it sounds, because as you can see, there's lumps of it in the bottom that are still dry. So I think what I'm going to have to do is just get in here with my hand and break up the lumps and make sure everything is thoroughly wet. Yeah, there we go. Don't feel any more lumps. Okay. Okay, so what I'm going to do is I'm going to pour off the liquid into this bucket. And a lot of the lightweight ashy stuff is going to stay suspended in the water column. I have other videos about doing this. I've already reduced the volume by quite a bit. But I'm pouring it into a catch bucket, so anything that does make it out of this bucket that has value is going to be in there. So get this stuff all wet and agitated again. Thoroughly mixed. Give it a few seconds. The gold is 19 times heavier than the water. It falls out of the water column pretty darn quickly. The larger grains of leftover silica from grinding up the silicon dyes are going to stay behind. The gold's going to stay behind. Copper, steel that have made it through the mesh are going to stay behind. And I'm going to keep doing this until the water that comes off is pretty clear. That's going to mean I've got the bulk of the ashy stuff out of it. That ashy stuff has no value. There's no precious metals in it. And all it'll do is clog my filters later when I'm trying to filter off the gold-bearing solution. It's okay that this bucket's overflowing. Anything heavy is going to be in the bottom of it. The stuff at the top that's overflowing is just dirty water. Yeah, we dramatically reduced the volume of material here, but there's still a lot of it. I am contemplating how I'm going to proceed once I'm done with this, because there's a lot of material here. A couple of options. You see how much I've reduced the material? There was a lot more than that in there when I started. I think I'll give it one more wash anyway. So even though I've dramatically reduced the volume, there's still a fair amount of material here. One more time. Not quite as clear as I'd like it. Still a lot of light stuff coming off. Okay. I'll call that done. A little more of the water off. Sits for a few seconds, the water will separate from the pile of stuff there, and you can pour a little more of it off. Now we've got the stuff in this bucket. Most of it's just garbage, but a little bit of good stuff might have come through. So we're going to do the same thing with it. Hope I'm in frame. Going to pour the liquid off into this pan. And that's a lot of light ashy stuff in there. But just in case some good stuff made it over, we'll do the same thing. We'll get it agitated, give it a couple seconds and pour it off. Again, the gold's going to settle out real quick. The amount of material in this bucket is getting very small. Well, not too much of the value made it over here. Well, I'm going to wash this stuff until the water's coming off clear, then I'm going to add it to the other bucket. Actually, I think I'm going to add that bucket to this one. Makes more sense. That bucket's too big for anything. Yeah, not much made it over. Okay. So I'm going to put this stuff in here, into this bucket. That's it. That's pretty clear. Okay, and here's our concentrate. That's going to contain almost all the values from Nick's chips right there in that relatively small volume of material. This is easier to deal with, but it's still too much for one beaker, so I have a choice. I can either set up my sluice and sluice this and create a super concentrate, or I can just divide it up between a couple of beakers and process it. Well, being as the weather's been so crummy and there's no improvement in sight, I think it'd be easier just to divide it up into a couple of beakers and process it rather than try and set up the sluice and work between rain showers. So I think I'll just divide it up. Okay, once the fume hood is free of processing the oversized stuff, we'll get on to this. Yeah, we're kind of between rainstorms. I had to wade out to my lab, literally. Let me show you. We are underwater here. We're flooded. But there's more rain coming. So I wanted to get started on this while I had the opportunity for a little while to work on it. This beaker here, just took it out of the fume hood. It looks like the acids have dissolved as much of the metal out of this as they're gonna. I wouldn't be surprised if there's still a little bit of metal down in there. I don't know, we'll see. There's still all kinds of crud down in there, solids of all kinds of stuff, but you know, there might still be a little metal hiding in there, but I think we've taken out as much as we can. I tested this liquid off camera. It still has significant silver in it, so I'm going to pour it into this beaker, which has the silver-rich liquid in it, and then we'll hit this with some aqua regia and see if we can dissolve the gold out of it that I could see. And then once the aqua regia's done its thing, we'll start on the IC chip remains that I did the gravity separation on yesterday. So I got to get working. There's a lot to do. Alright, here we go. I have transferred the gunk left over in the bottom of that big beaker to a smaller beaker because I'm going to need all my big beakers here in a bit to process the bulk of the material that I did the gravity separation on yesterday. So I'm going to get this started in a smaller beaker. Going to add some uriatic acid to it and get it up to about the 400 milliliter mark. There's not that much gold in there. I swirled it around while I was rinsing it, and I could see flecks of gold scattered through it, but I know there's not a huge amount of gold there. So, and then we need a little, nitric acid on it. Yeah, this big beaker back here, this has got all the silver solution in it. It needs to settle out again because it's all turbid after dumping the contents of this other beaker into it and the rinse water too. So I'm not going to put a huge amount of nitric acid in here. I don't want to over nitric it. Okay, and get the hot plate turned on, warming up, and the fume hood on. Get that cooking, see how it goes. In the meantime, I need to divide up the material from yesterday into two different big beakers. Alright, here's the bucket from yesterday. Got the remains after the gravity separation. I'm just going to sort of divide it roughly in half and try to get about half of it in one beaker and half in the other. Most of the gold is probably down in this lower corner because the gold's heavy, so it's probably sunk down there. So I want to try and get this roughly the same amount of gold in both beakers, so this is why I'm dividing it like this. And the reason I'm not putting it all in one beaker is there's just too much material here. Oops. Sloppy. That's not good. There's just too much material here. it'll be too thick on the bottom of the beaker and the chemicals won't be able to react with it properly. Okay, I'm calling that roughly half, and the other half is going in this beaker. This stage you don't see any of the gold, but you know it's there. Everything into the beaker. Like I say, a lot of the gold is probably down in that bottom corner of the bucket. I want to make sure I don't leave any residue in there. Get it all in. Drain off this water. You don't need it. Okay, once the fume hood's available, we're ready to do the same sort of acid treatment that we did on the oversized stuff to leach out the base metals. Then we can do aqua regia to get the gold out. Starting to get a reaction, got some serious bubbling going on in there. Darkening up a little bit. We'll give it a test for gold once it looks like the aqua regia is pretty much done. Alright, it's been a while. I think the bubbling that's going on there is boiling. I'm not seeing any more fume production. I don't think we're actually getting any more metal in this solution. I'm going to turn this hot plate off. Pull this stuff out and we'll do a stannous chloride test on it. Okay, I need to wrap this up and get things buttoned up because we got yet another storm coming and it looks like it's going to be pretty rough. Just what we need, more rain. So let's see what we've got here. Okay, and here's some fresh stannous chloride solution I just made. Okay, so we do have a pretty good indication of gold in solution. I mean, I've seen stronger indications, but I've seen a lot of weaker ones too. So there's some gold in this solution right here. Alright, it's not a huge amount, I don't think. Probably a small fraction of a gram, but hey, it's some gold. I think I said up front, you would have to judge for yourself whether you think it's worth the effort of going after that gold in the oversized, mostly metal, mostly steel fraction of the IC chips. Me, I wanted to try and get it all for this test. So what I'm going to do is, I'm not going to try and drop this gold out of solution right now. What I'm going to do is I'm going to get to work after this next storm is done on these two beakers of stuff here. I'll get them in the fume hood, get some nitric acid on them, and start extracting the metals out of them, the base metals, and then once they're done, we'll do the aqua regia on them to get the gold out, and I'll just add this to the aqua regia that I get from those two beakers, and we'll drop all the gold together and see how much we get. But right now, I got to start battening down the hatches. It's getting windy, and the storms are just a couple miles away. Alright, here we are. It's another day. It's not raining at the moment. The sun's actually out, and you cannot imagine how humid it is standing in the middle of this lake that used to be our backyard. Okay. Gonna make hay while the sun shines. I've got the two beakers full of the IC chip remains after the gravity separation. after the incineration, the pulverization, and the gravity separation. Divided it up into 2 beakers. I'm going to put some distilled water in each beaker. About 800 milliliters or so. Well, up to the 800 milliliter mark or so. Okay. Alright, now that I've got the water in, it's time for some acid. Let me get the fume hood going. Getting up the rest of that bottle in. And open up a new bottle and do the other one. And we're just going to dissolve the base metals out of here. Getting some fumage already. About the same amount of acid. Bubbling over there too. Alright. So this is going to take a while. It may not even be done today. Going to let it go until I think the nitric acid has dissolved all the base metals out. I'll stir it up every once in a while and we'll just let it cook, and later on we'll test it and see how much silver we're getting dissolved into solution too. Okay, it's been a couple minutes, got good vigorous reactions going in both beakers. Like I say, this is going to take a while. So in the meantime, I'm going to filter this liquid that contains all the silver we got off the oversized stuff. It is some really scummy, nasty looking stuff. It's got a layer of crud down here on the bottom. It's got some kind of scum floating on top. And it's got the remains of a broken watch glass in it. I managed to break the watch glass that was sitting on top of it. So I need to filter this stuff and get it clean, and then get it back in a big beaker and start cementing out the silver. Because I need to get that done because there's going to be more silver coming from the stuff that's in the fume hood. So I have a limited amount of glassware. It's all going to be in use shortly. So let me get the scum filtered off of this stuff, and then we'll start cementing out the silver. Interesting. That is not coming through nice and clear. That looks like we got a silver chloride issue there. Some sort of milky precipitate. Where that's coming from, I don't know. I just used distilled water to wet down the filter. Okay, I got my big Buckner funnel out, because the filtration through this funnel was just taking way too long. It was not working very well. You can see how plugged up it is. And I don't know, maybe just filtering this stuff out is responsible for the difference in the color. I mean, there's still something suspended in here. I'm going to have to filter this again. But taking whatever this out has certainly lightened the color up a lot. It took 4, count them, 4 passes through the filter to get this stuff looking reasonably clean. I don't know what all that sediment in there was. Some of it was kind of acting like silver chloride, although I don't know where a source of chlorine would have come from. to cause it. And some of it was sort of a reddish brown, so I don't know what sediments we had in here, but I think we finally got it reasonably clean. So what I'm going to do is I'm going to dump this back in the beaker and put a coil of copper wire in it and see if we can cement out some silver. Still full almost to the brim. Okay, let's see. Since I broke my watch glass, I'm going to have to get another one out of storage. Here's a coil of copper. I've used it before for cementing silver out. It's a little dirty looking, but it'll do the job. So we'll just let that sit in there. And oh, I see something happening already. Oh yeah. I don't know if it's going to show up on camera, but look at that. Look at that. See if I can get a better focus. Wow, look at that. Immediate. There's a lot of silver in there. Gonna get a lot of silver out of this liquid. Alright, let me find a watch glass to cover it up. And then I think I'm going to go to lunch. It's been a busy morning. Alright, I just got back from lunch. Gone maybe hour and a half. Stopped at the grocery store too, so I've been gone a little while. This is what I find when I get back. And I am not ashamed to admit that I have no earthly idea what's going on in that beaker. That does not look like silver cementation. This stuff that's collected at the bottom doesn't look like cement silver. I mean, if anything, it looks like silver chloride, but I don't know why putting copper into there would cause silver chloride to precipitate out. I mean, there's no chlorine in the copper. So I don't know. It's probably something else, or maybe there's something in here that is causing the silver to precipitate out like that. There could be some other metallic salt in there. I don't know. But I've never seen this before. This is the problem with doing random batches of IC chips. You think you've got it figured out, and then you get a batch of chips that just goes off the wall on you. You don't know what's going on. It's because, you know, no two batches are exactly the same. Some of those chips may have used strange elements in them. Who knows? But I'm just going to let this sit. It looks like it's slowly clearing from the top down. So we'll let it sit over the next few days, see what we get. I'm hoping there's some silver in there that's recoverable. We'll see. Meanwhile, okay, I put a little bit more acid in these two beakers before I went to lunch, and when I came back I just stirred it up because there didn't seem to be much activity going on anymore. And we got some more brown fumes, so not quite done dissolving metal. There's still some in there. Just got to keep it stirred up. And I'll show you a little trick. I'll show it to you later, but I got a piece of copper here, copper wire, and I can tell if the acid's used up or not just by sticking this in there. And if I see bubbles coming off of it, I know there's still active acid in there. If there's no bubbles, I'll know that the acid's all used up and it's time to add more. But I stuck this in there. There was still acid. I gave it a stir, and there was activity started up again. So we'll wait and see on what happens. I'll give it some more stirs and check it. And if all the acid gets used up, I'll have to assume that the metal has used it up, and there's probably more metal that needs to be treated with the acid. If all the activity dies down and there's still active acid in there, then I can probably safely assume that all the metal's been used up. So it's just a waiting game now, and it may be a while. This may go on for a day or so, especially since I got other things to do.